Okay, well, if I can say good afternoon to everybody, I'm David Hume, the CEO of the FutureDAMS Research Consortium, and we're very pleased to welcome you this afternoon to a public lecture by Mark Smith and Matthew McCartney, both at the International Water Management Institute. We're really pleased to be able to welcome Mark and Matthew to this webinar. It's a special week for us because we're having our annual forum. So we're getting our 80 researchers and activists in water management across Africa and Asia and Europe together. Last year we had it in a splendid, very participatory meeting. This year we're doing it as a Zoom conference, but we thought it would be good, apart from the management stuff we're doing, to have an exciting webinar so that we can actually think about the agenda, think about future agendas, think about key intellectual arguments, key debates that are shaping what's happening in water management. So very glad to welcome Mark and Matthew here. They're going to be talking about integrating natural and built infrastructure in water resource development, what's stopping us. They'll talk for around about 30 minutes, and then we'll move on to question and answers. Potentially we've got up till 4:30, but we may draw it to a halt before then, depending on how many people can hang in with us. But with those words of introduction, then can I pass over to you, Mark? I think you're going to start off. And thank you again.
Great, thank you very much, David, and thank you to the FutureDAMS team for this invitation for IWMI to take part in, to give this webinar and take part in your forum. It's very welcome opportunity to engage with what I know has been I've been in touch with the FutureDAMS project at various times myself, and of course IWMI's been engaged in a couple of different ways. So really pleased to be able to contribute to the dialogue that you're all having. Yeah, as David said, we've elected partly to keep things lively in the webinar format, which I think we're all used to now, can be and not a struggle, that's the wrong word, but it helps to try and keep it lively. We'll split the presentation between myself and Matthew. What we wanted to do, as David introduced, was really look at the relationship between nature-based solutions and water infrastructure. What are the barriers, some of the barriers to application of nature-based solutions in water security? How is that relating to the policy debates? And how can data help with decision making and help to overcome some of those barriers? So first you'll hear a few slides from me, principally around the framing of the issues and policy, and then we'll go into a bit of the exploring some of the data with Matthew. See if I can advance the slide. There we go. So there's really been a huge explosion, really, in the attention given in policy debates, in policy circles, to nature-based solutions in the last 2 years, I would say. It's of course nature-based solutions, the idea of natural infrastructure for water. It's been around probably for a decade, been talked about for a decade in those terms, as I'll come to in a minute. It's certainly nothing brand new in a way. So it's been under a lot of discussion for a few years, but in the last 2 years it's just really exploded, and it's prominent now in EU policy, in, for example, German development policy, now UK development policy. More and more we saw it, and I suppose I really first experienced this real explosion of this set of issues that I'd been talking about and working on for the last decade. The fact that it was really mainstream now at the climate summit in New York last year in 2019, where all of a sudden everyone was talking about it, as if it was something they were all doing, whereas in the years past we've been trying to convince them to pay attention. So that felt like a breakthrough. And we similarly, in the Biodiversity Summit this year in 2020, similarly high profile. And of course, in the UK presidency of COP26, we hear a lot of ambition for nature-based solutions. And so one of the things that concerns me, that we've been thinking about, that you'll hear Matthew talk about a little bit, is there's such an opportunity therefore now. There's a window of opportunity now for nature-based solutions in regard to a number of things, but water is one of them. And we better seize it. And so if we're going to seize that opportunity, how do we do that? How do we make the best job of that? How do we overcome those barriers around data, those barriers around institutions and political economy and so on? So on the screen now you see a definition of nature-based solutions that is used by IUCN, and really in this framing, which is one that I personally reasonably like, nature-based solutions are trying to address societal challenges, providing benefits to both biodiversity and to people by protecting, managing, and restoring ecosystems. So in that sense, a pretty simple idea, simple concept. But why this convergence of interest now? Why this explosion of interest in nature-based solutions now? And my own view is I think what you see is there's this coming together of possibilities, this driven by the challenges, driven by the deepening need and the deepening understanding in the policy world and also in the political world of the need to address challenges, big global mega challenges related to climate, related to biodiversity, related to food, to a degree in terms of recognition anyways, water also. And so nature-based solutions has kind of caught the imagination in part, I think, because it offers multiple benefits. It offers ways of gaining multiple benefits from particular sets of interventions. And alongside that, there is increasing understanding, I think, including at that policy and that political level, of these global mega challenges as a systems problem, as something that we have to tackle, we have to invest in, we have to make policy for, we have to design for, in ways that treat the problems as systems. And to me, that's relatively new. That at that level, people are conceptualizing the challenges as systems challenges. And so one of the appeals, therefore, of nature-based solutions, because it touches upon all these different challenges, or they touch upon all these different challenges and offer these multiple benefits, is it provides a tangible, indeed, with a relatively little introduction, a tangible and reasonably well understandable way of dealing with systems and dealing with complexity. And so by conceptualizing this really complex set of problems around a relatively simple set of systems tools, of which nature-based solutions is one, at least at that policy level, that offers a way forward. And I think that's why it's caught people's imagination at that level. So what do we do then with this opportunity? What's the opportunity now? There's this big focus on nature-based solutions over the last 2 years. What do we do with this opportunity? Well, I think we have to show rapidly that concrete action is possible. So you can translate this talk and conceptualization into real action. We have to show that it's possible for investment to flow into nature-based solutions, and that means unpicking a set of barriers to having investment flow into these kinds of solutions, and show that benefits can be delivered. That benefits can be delivered for those challenges, water, food, nature, climate, etc., but also to people and to in relation to development objectives, in relation to poverty, in relation to inclusion and equality. We have to show how that can be done. So what do we mean then, just to further frame this out, what are we talking about when we talk about nature-based solutions for water security? Anyone who's seen me speak before has probably seen this slide. I've talked about this before, seen this slide about 10 times, but I do find it really useful. You know, we're used to tackling, in a way, we're used to tackling, especially if we go back in time a little bit, we're used to tackling water security from a engineering, from an infrastructure starting point. So the table that you see on the screen is just a way of conceptualizing that engineering framing for why do we use built infrastructure, and how can we use natural infrastructure to help meet some of those service requirements. So you see down the left-hand side a set of what I call facilities, so storage, conveyance, flood regulation, water filtration, coastal protection, etc. And in the middle column, the kinds of built infrastructure that we're used to, and I'm sure this community is highly used to working with and assessing and analyzing, that investors are used to working with and putting their money into, and being able to measure what should be the returns and benefits from putting investment into those kinds of infrastructure. And then on the right-hand side, the natural analogs that provide those same kinds of services and that complement the built infrastructure, that help to deliver the facilities that you see on the left-hand side. So storage from upland soils and lakes and groundwater, of course, conveyance through rivers, flood regulation from floodplains and wetlands, etc. Filtration by wetlands, soils, and so on. So on the screen now, you see some examples of how natural infrastructure relates to those services, relates to things people need and use. And of course, there's multiple types. There's multiple, multitudinous different types of possible natural infrastructure for water across landscapes, across basins, and so on. And all of those multitude of types, they have complex interactions, socially, economically, ecologically, and maybe more than we're used to with built infrastructure. And they're highly variable, maybe in ways that built infrastructure, in engineering built infrastructure, we're much more able to control that variability. And so therefore there's uncertainty attached to these kinds of natural infrastructure, to these kinds of services. And different kinds of uncertainty than we're used to with engineered infrastructure. And that can be, that's one of the challenges. So what's new? What's new and what's not new if we're talking about natural infrastructure and built infrastructure, natural infrastructure as an alternative or a complement to built infrastructure? In a way, not very much is new, because ecosystem services, whatever they were called historically, have always been part of water resource management. But they've tended to use a different language. And so on the slide here is just an illustration of that. You know, in engineering, in operation of built infrastructure, in the investment and economics of built infrastructure, everyone's used to talking about operations and maintenance and refurbishment. But for ecosystems, we call those same things resource management, conservation, restoration, etc. So there are differences in language. There are differences, therefore, linked to that, I think, are differences then in how we value these different kinds of infrastructure, where they fit within different governance frameworks, where their home is within different policy frameworks. So natural infrastructure, therefore, is it's not new, but what is new, because those services have always been there, but what is new is that by thinking with this framing of nature-based solutions and natural and built infrastructure, it forces us, it makes us to put them in one strategy, to put the built infrastructure and the natural infrastructure into one strategy and one, therefore, investment package, potentially one investment packages for infrastructure built and natural, and use a portfolio approach. So thinking of how do we, that if in working with portfolios, we can work across basins, across watersheds, etc., so that we have both natural infrastructure and built infrastructure, giving a set of services and functions that we need. So on the slide here is a depiction of the benefits that you have in a natural basin, a natural unmodified basin, versus underneath a depiction of the benefits that you have from a much more intensively modified and utilized basin. And the opportunity then by bringing together built and natural infrastructure is to combine those and find a better balance that better meets people's needs, better meets nature's needs. And once we start thinking in those portfolio terms, the opportunity or the need is to weigh benefits and their associated costs across multiple different objectives. So what are we trying to do? What sets of needs are we trying to meet? What's the combination of bringing together those different kinds of benefits to help meet the objectives that we have in a basin? But to do that, we have to have the right kind of conceptualization of what those benefits are and be able to quantify them, so that we can compare them and make choices and make decisions about where we put investment, where we put management effort, how we organize governance in order to get that combination of built and natural infrastructure in the way that we need. So on the right-hand side of the slide is just, I don't want to go into the details here. It comes from the Wise Up project that I worked on with Matthew and with other partners, including I know many of the FutureDAMS partners. But the point of that graphic is that if as you see on the, if you like, the right-hand column of that graphic, where the mindset in identifying, well, what's the infrastructure combination that we want to work with in this particular basin, if the mindset is to define that very narrowly around irrigation and hydropower, then that's the mix you get. Whereas if the conceptualization of developing and managing a portfolio of infrastructure built and natural in that basin, associated with built infrastructure investment, is wider and incorporates natural infrastructure and the benefits that people need from that, from ecosystem services, then you get a much larger, wider mix of benefits and different kinds of return on investment for different kinds of people. So the key thing therefore then is to be able to quantify and compare benefits of built and natural infrastructure, as well as the risks attached to them and the uncertainties attached to them. And if we don't get good at doing that, then we risk missing out on this opportunity that I spoke about at the start, the opportunity that this explosion in mainstream policy interest in nature-based solutions and in natural infrastructure, the way they're framed for water, that offers right now. And otherwise, governments and planners and investors will remain wary, will not be able to work at the kind of scale that's really needed to drive home solutions to those big challenges at the scales that we need. And this is a question worth worth hundreds of billions of dollars, really. You know, projections for water infrastructure, needed investments in water infrastructure through 2030 run into the trillions of dollars. I mean, and so if you can start using some of that investment for natural infrastructure complements to the built infrastructure, that's hundreds of billions of dollars that could be going into nature-based solutions. So overcoming the barriers to help us quantify and compare, build these portfolios of built and natural infrastructure is a critical question for the eventual success or failure of nature-based solutions for water. So with that, I will turn over now to Matthew. And Matthew, I will run the slides from here, and you'll pick up those issues. Matthew.
Great, thank you very much, Mark. So as Mark has just discussed, there's a very big focus now on natural-based solutions, but this needs to be translated into real action. And a recent, I think the 2018 World Water Development Report estimated that only 5% of investments into water can be classified as nature-based solutions. And natural infrastructure as a subset of nature-based solutions is a lot less. So there's various different constraints to incorporating natural infrastructure in these portfolios that Mark's talked about. But a key constraint to investment is actually the difficulty of working with natural processes at a basin scale. So in contrast to built infrastructure, the evidence base for context-specific understanding of the linkages between natural infrastructure and hydrology, for example, is fairly poor. There's relatively limited quantitative understanding of the benefits natural infrastructure provide and how they explicitly relate to river and water flows. So in this part of the discussion, I'm going to present some research that IWMI has conducted in which we have attempted to develop methods to provide quantitative, context-specific information specifically related to these portfolios, and in particular for the nature-based part of the portfolio. So in this slide that's shown now, this is a simple conceptualization of the link between natural and built infrastructure, illustrating synergies and trade-offs. It was developed as part of the Wise Up project that Mark just mentioned, and it was developed specifically for the Tana River Basin in Kenya, but we think it's more generally applicable. And just to say that we adopted an ecosystem services perspective for this, since ecosystem services clarifies the relationship between ecological processes and human well-being. And we envisage two types of natural infrastructure. First, that occurring upstream of built infrastructure, and second, that occurring downstream of built infrastructure. That built infrastructure has obviously been developed for things like hydroelectricity and irrigation water, as Mark just alluded to. So upstream natural infrastructure affects the rainfall runoff response of a catchment, splitting rainfall between event-based and longer-term runoff and evaporation. This, in turn, determines the water yield of a catchment, extent of groundwater recharge, magnitude of natural flow regulation and sediment yield, all of which affect the technical performance of the built infrastructure located downstream. So the specific catchment characteristics that influence runoff and soil erosion are things like vegetation, soil, geology, slope, catchment size. And of course, land use and land cover, and hence land management practices, can also modify these processes and provide a means by which landscapes can be managed to influence the upstream services and improve or disprove or make worse the performance of built infrastructure. So for example, investments in afforestation, reforestation, riparian buffers, soil and water conservation, etc., affect runoff and soil erosion, which in turn affect the reliability, resilience and vulnerability of downstream infrastructure, built infrastructure. Then downstream of built infrastructure, there's also natural infrastructure, which also provides a range of ecosystem services that are dependent this time on river flows. So the alteration of that flow regime by built infrastructure can significantly affect these ecosystem services. For example, the most common impact of a dam is increased flow regulation, and therefore a decrease in flood peaks and an increase in low flows. And in addition to trapping of sediments in a reservoir and changes to water chemistry, these all result in complex alterations of downstream riparian ecosystems, affecting both terrestrial and aquatic flora and fauna. This in turn affects ecosystem services such as freshwater and nearshore marine fisheries, floodplain grazing, flood recession agriculture, as well as river and coastal geomorphology. So with that in mind, next slide, please, Mark. This is an example of just a couple of ecosystem services that we looked at in the Tana River. The one on the left shows upstream soil retention, and the one on the right shows nearshore marine fisheries. So first, looking at the left-hand side, these graphs show the results of computer modelling, illustrating average annual sediment load from a catchment under both current conditions, which is the dark bars, and with investment in natural infrastructure, which is the hash bars. So that investment would be in, like I said, in soil water conservation, buffer strips, terracing, etc. It also looks at different time horizons, so the 2030s, 2050s, and 2080s. And we looked at, although it's not shown here, we looked at also different climate change scenarios. But the bottom graph on the left-hand side shows the implications for reservoir storage now and in the future if there was investment in the natural infrastructure. So you can see that storage in this reservoir, Masinga, there'd be an extra 118 million cubic meters of storage if there was the investment in the natural infrastructure. So that the performance of the storage is improved over time as a consequence of investing in the natural infrastructure in the upper catchment. The graph on the right-hand side shows our annual flow, which is measured at a gauge close to the Tana River estuary, affects marine fisheries production. So marine fisheries depend on nutrients washed out to sea by the river. And of course, flow is not the only factor affecting fisheries. There's many other things that affect it, not least of which is fishing effort and how much time people spend actually fishing, which is why there's a scatter in the points. Nevertheless, there's a reasonable relationship which could be used to predict how fisheries would be affected if the flow regime was altered. For example, if more water is removed for irrigation. So these sorts of relationships, which we term benefit functions, were used to analyse the trade-offs of different configurations of natural and built infrastructure linked to rainfall, flow, and different dam operation. That you can also enable comparison of irrigation and hydropower benefits from the dams with the different ecosystem services. So just as Mark showed, it's possible to do fairly crude, but simple but crude economic analysis to look at the different, to make comparisons across the different benefits. And these benefit functions were also used by the University of Manchester team in multi-criteria optimization modelling, which was a systematic approach to assessing a range of different options across different development scenarios and dam operating options across different climate change scenarios. So it provides a way, these sorts of empirical relationships provide a way of directly comparing benefits from nature-based and built infrastructure and looking at as Mark said, looking at the portfolios. Next slide, please, Mark. So this is now a different study conducted in the Zambezi River, Southern Africa. The objective of this study was to determine the impacts of natural infrastructure on flow regimes, and in particular, how natural ecosystems found across the basin. So when we're talking about natural ecosystems here, we're talking about floodplains, headwater wetlands, and the the sort of forest that occurs there, which is Miambo woodland. So these are the major ecosystems across that basin. So how those natural ecosystems impact flood and drought flow. So a common attribute of natural ecosystems, both forest and wetlands, for example, is that they attenuate flows. That means they reduce flood peaks and maintain flows during dry periods. Often they're conceptualized as sponges. So that, as I said, reducing floods and maintaining dry season river flow. But actually rarely is this phenomenon actually quantified, and many scientific studies actually raise questions about whether ecosystems actually function in this way at all. So there's various different studies. There have been lots of studies over the years providing conflicting information from ecosystems all over the world. And so it makes it very difficult to ascertain generic results, and it makes it very difficult to actually quantify the impacts of different ecosystems. And it's because they're not quantified that these services are rarely, if ever, or explicitly factored into water resources planning and management. So one reason that they're not thought about in these portfolios is because there's not enough quantitative information. So this study was trying to ascertain what the impacts would be. Next slide, please, Mark. And we selected the Zambezi River Basin in part because there's actually a lot of data available. In total, across the basin, there's more than 100 flow gauging stations with more than 25 years of daily flow data. And the method we developed utilizes observed stream flow records and what we call flow duration curves, which are curves which show the proportion of time that flows are exceeded, to derive in a very simple way simulated time series of flow in the absence of a specific ecosystem. And then the idea was that this flow in the absence of the ecosystem could be compared with an observed time series, which occurs within the presence of the ecosystem, to evaluate the impact of the ecosystem on the flow regime. Then next, please, Mark. So it was a three-step approach. First of all, we estimated what we called a reference flow duration curve, which was derived from flow gauges on unregulated rivers close to the site of interest, but in the absence of the ecosystem of interest. So we were looking at wetlands, we would look at a river we were looking at a specific wetland, we would look at a river that didn't have wetlands on it, and look at the flow regime there, and from that derive a flow duration curve. And this curve was standardized by dividing through by the long-term mean discharge as estimated from the observed records. And this is what we call a reference flow duration curve, or a regional curve. Next, please, Mark. We could then convert this reference or non-dimensional flow duration curve to an actual flow duration curve at a site immediately downstream of the ecosystem of interest, simply by multiplying the standard curve by the long-term mean discharge at that site. This is what the flow duration curve would have been if the specific ecosystem was not present. Next, please, Mark. We could then convert this actual flow duration curve at the downstream location into a continuous stream flow hydrograph using an interpolation technique. So this is a time series of flows that would have occurred in the absence of the ecosystem. It's now possible then to compare the time series of observed flows, that's with the ecosystem, with the time series of flows that would have occurred if it wasn't there. And the beauty of this approach is that it can all be done in a spreadsheet. It's an empirical approach that doesn't depend on any complex modeling, nor on any assumptions about how the ecosystem should function. Next slide, please, Mark. So this graph shows some of the results for one specific location, which is the Lushui floodplain on the Lushui River in Zambia. So this is a floodplain that has an area of 211 kilometers squared in a catchment of just under 4,000 kilometers squared. And as you can see, daily flows are shown for a 15-year period. The solid line shows the flow that was measured downstream of the floodplain, and the dashed line shows the flow that would have occurred in the absence of that floodplain. Next slide. Next, please, Mark. And then this second graph zooms in on a particular 2-year period. So from October 1980 to September 1982. And it's clear that in this case, the floodplain is attenuating flows. Flood peaks are reduced and low flows are increased. Next slide, please, Mark. And then because we can now compare the time series of flows with and without the floodplain, it's possible to quantify the impact of the floodplain on specific flow characteristics. So in a way that hydrologists do all the time, we can look at specific flow characteristics. So this graph, for example, shows how we can quantify the impact on flood flows. And this is done through a standard hydrological technique known as flood frequency analysis, which enables a return period of flows to be computed. And the graph shows the flood frequency curves derived with the floodplain present, that's the solid line, and in the absence, the dashed line. And you can quite clearly see that as the return period of the flows increases, the impact of the floodplain becomes more pronounced, and it's reducing that peak flood flow. And then the table shows that the same information in just in a tabular form. So these results are quantifying the effect of the floodplain on flood magnitude. And thus for a flood with a return period, for example, of 2 years, that's the flood which would occur on average every 2 years, the presence of the floodplain reduces the flood peak from 73 to 47 meters cubed per second. Similarly, for a flood with a return period of 50 years, that's the flood which occurs on average every 50 years, the presence of the floodplain reduces the flood peak from 122 to 75 meters cubed per second. So we have a way of actually quantifying in exactly the same way as you would with a dam, the impact on the flood flow. And you can do the same thing with, for instance, low flow characteristics, looking at base flows, etc. So you have a way of actually quantifying the impact of the ecosystem on the flows, and again, you can make comparisons with built infrastructure. Next slide, please, Mark. So in conclusion, we just heard from Mark about the huge investment that's needed in water by 2030 if the water-related SDGs are to be achieved. Something like more than 6.5 trillion is needed. For resilience and sustainability, it's absolutely imperative that I would say that nature-based solutions and specifically natural infrastructure is a significant part of this investment. If it's focused predominantly on traditional engineering infrastructure, then the environmental and social costs will be absolutely immense. And I would argue it's almost certainly unsustainable in the long term. However, much needs to be done to enable integration of natural infrastructure with traditional built infrastructure. And one of the major stumbling blocks remains lack of quantitative information on the performance of natural infrastructure. And of course, as Mark's also pointed out, traditional engineering approaches have been developed over many, many years. And now we need to make the transition to a new way of doing things quite quickly, or in fact, very quickly. And it's a major challenge. But as I hope I've just illustrated here, it is possible to develop relatively simple approaches that facilitate the quantification of performance of natural infrastructure in a way that enables direct comparison with traditional built infrastructure. And so with that, I say thank you very much. Thank you.
We seem to be concluding that these natural infrastructure, it's a great idea, but presenting it always as win-win does need to be looked at. These ideas do need to be tested and explored. There's clearly a need for evidence, as Mark and Matthew argued very strongly early on. But the ways in which that evidence is collected is clearly going to have to move away from long-term academic intensive research into things that can generate evidence that will allow decisions in the sorts of timeframes that are needed, not come back in 10 years' time. And certainly when we've looked at these governance issues that have been mentioned and the institutional issues, even the idea of the sort of the business models that could be used, we're exploring these in FutureDAMS, but we are finding, I suppose, what we could call our interdisciplinary dilemma. We were discussing this morning in our initial plenary session, which is so often the answer when you start to look at the governance problems or the institutions that are needed, is it needs to be contextualized. It's got to fit that specific country and perhaps that particular problem. And that does generate enormous questions about how to harness local political forces so that the institutions that are created can be supported. The simple solutions that academics have often come up with, such as market is best or community is best or state is best, are clearly wrong. One always needs some combination, some partnership of these actors working together. So I think, yeah, when we have our interdisciplinary section, you've certainly left us with an agenda to try and think about how one could come up with means of moving towards institutional frameworks that are likely to fit context, but don't say wait forever. On behalf of all of us here, if people want to show their, I think there are the various reactions that one can go, but Mark and Matthew, that was really great. When I asked whether you could provide us with a webinar, that was just what I was thinking about, something that's really got us thinking, a set of issues that whatever we're looking at, whatever our specialization, we have to think about how natural infrastructure and built infrastructure can and cannot be fitted together on that. So thank you very much for that. Thanks to all the audience. You've hung in and that's been really good. And I'll say good night now, but please do look at our webinars. We've got a whole series of great webinars coming up in FutureDAMS, and we look forward to working with you all in the future. Good night.